Jules Oerting, former head of EC3 Europol, once said that it's, for cybercrime, increasingly hard to prosecute. And I agree. Because let me show you the classic way of working for the police. Simplified. We start with a report. We start with the victim. Let's say the victim is beaten up. He needs to file a report. I'm beaten up. Or he's dead. Then he doesn't need to file a report. So then we start our investigation, and we investigate, and we investigate, and we investigate, and eventually we have attribution. Who done it? Now this is a pretty expensive way of working. This is a pretty expensive way of keeping the world a safer place. We can change that. And let me tell you, for cybercrime, it isn't really working. Tor, encryption, bitcoins, borders, so many reasons why it's not really working. So we need to change this. And the first change I want to propose is we go from a report to a data set. We no longer start at the victim, we start at the infrastructure. The infrastructure that the criminal uses to attack the victim. This is where the data is. This is where the information is. This is where we can get the clues to stop the criminal and to help the victim. But that's still not enough. Because it's still, even from here, it's pretty expensive. So we need a new model. So I propose a new model for policing in cybercrime. Enter the dragon. There is so much more we can do if we have this data set. From the data set, we can do damage mitigation, make sure that the damage stays within bound. We can do victim notification. Now that's a police job, if you ask me. And we can do disruption, making the business model of these criminals so expensive that they'll have to stop. And if we do those things right, then maybe we could even decapitate the dragon. This is a scary thought for police. But this is where we want to go. And we want to do this not alone. Police is only just one little player in a whole big field of cybersecurity. We need other people to move the ball of dung. And we don't need regular operation, we need operational cooperation. Because we've been working together with a lot of partners. What we need is working together with partners and being able to share information that really matters. And we want to share that with a lot of partners. Obviously, police from other countries. These borders, we need to get rid of these borders. This car is half Dutch and half German. 1, 2, Polizei. There you have it. Now imagine, you are a Dutch cop and you're following a criminal, a drug trafficker, across the highway, and he crosses into Germany. The only thing you see at the border of Germany is that the speed limit stops. For the rest, there is no border. So he drives into Germany. Now we are the police, so we need to stop here. That's not our territory. And we need to phone our German colleagues. Hallo, bitte, ja, can you please follow this car for me? Now that doesn't work. So what have we done? We have decided that under certain conditions, the Dutch car can enter Germany and the German car can enter the Dutch territory. And hell, do we need something like that for cybercrime as well? So that is police cooperation. But even more important is the cooperation with the IT security industry. And this slide, police and IT security industry, I try to insult them both here. The IT security industry. And we wanted a project to see if we could work out the decapitated dragon with somebody from the IT security industry. It needed to be a simple, small, specific project. Why simple? We don't have that big capacity. We only have a few people to do this. So a project. So we went to Kaspersky, because we've been working with them before and we know they're eager to do kind of things like this. We went to Kaspersky and we said, hey, Kaspersky, hi. How about you and me, huh? And they said, yes, okay. So we said, What do you have? What do you have for our simple, small, specific project? And they gave us Carbonac.
It's not simple, not small, but really specific. This attack was mostly for the organization, financial institutions, and banks. And mainly, the targets were located in Russia, but then when we start cooperate with the law enforcement, we figure out that it's global threat. And that's when we came to attribution, we found out that the mainly, for example, cyber criminals are around the world. And basically, what is the difference for this APT? The criminals are using the APT techniques just to make money. Well, personally for me, this project started in the Starbucks. During the cooperation with the banks to fight with the ATM malware, I got a really good connection with the security guys in the banks. So one day, the guy from Ukraine, Kyiv, called me and asked for help with some mystery behavior of the ATM. So I was in Starbucks coffee, and the guy showed me this video. So here we got the suspect, we got the ATM, and 3, 2, 1, gotcha. The guy didn't touch anything. He was really lucky. Right place, right on time. Then I was like, what? What was that? But then, story continues. So it was really small number of banknotes. He grabbed it. Then, he started to send message to master. So this is kind of handshake. So this criminal should prove that he is in the right position. He is writing the number of banknotes that he just grabbed from the ATM. And then, 3, 2, 1, jackpot. So it will take several minutes to grab all money from the ATM. Then, first time when I was looking at the video, I was like, what the hell? And I asked, how many ATMs were actually robbed? The guy said, all of them. And that was like, okay, so I got the two theory. The insider, so criminal inside the bank, or the time bomb, so the Trojan. And the guy said, okay, so this is the hard drives. Find a Trojan, please. So I looked to this hard drives, and no malware was found. But I found the misconfiguration about the network, where the one ATM can actually connect to the other ATM, so it's really bad. But at the same time, I saw that there were connections from the bank. So I asked for hard drive from the bank that is system administrator computer, and I found the Carver malware over there. So I thought, well, you know the Carver, open source malware. So the guy was really lucky to get access to the ATMs. So I thought, oh, okay, problem solved. But then, not actually solved. Because in June, I've got once again, emergency phone call from the chief information security in other bank in Moscow, who asked me immediately go to the bank. And I said, what's going on? And the guy said, well, our domain controllers are trying to connect to the Chinese IP address. It's really bad situation for the domain controllers. So I was in the bank, and what do I find out? I grabbed lots of around maybe 100 hard drives copy, and I found out that infection inside this bank was for 2 months. 300 infected PCs was overall inside this bank. The infection started from the 3 spear phishing emails. So one of them was with a CPL file. The guy was asking to transfer $1 million from the one bank account to the other corporate account, and then details about this transfer was in attachment. Then we found out, for example, additional exploits, the Chinese exploits, but unfortunately not 0 days. 22 overall malicious application. It was Metapreter, additional tools like NetScanningZ, loaders, downloaders, blah, blah, blah. But at the end of that, we found the Carbonac itself. The malware that allowed us to unite all the cases around the world with a one APT. The Carbonac itself is a Carbonac-based malware that's open source, actually. And Analyst, the code that is hard-coded inside all samples. Carbonac.
Yeah. Hello, I'm Sergey, and what I want to do now, just give you a brief explanation how we were able to identify and track down the Carbonac malware, but what is the most important, not only to identify it, but to make an immediate incident response and help potential victims, banks and financial organizations to identify the Carbonac in their information system, stop the cyber criminal activity, and save their money. Please pay attention to the screen. What you see there is an actual string from a Carbonac sample, and it's a main fingerprint of the Carbonac malware. When the Carbonac infects a PC, it creates a .bin extension file on the infected machine. And the name of this file is always random. But the place, the catalog, the directory where it's stored in, it's always the same on any infected PC. What this file actually do? It's just a configuration file. When the computer is infected, the Carbonac malware creates this file and puts all the executable commands that it wants to perform on the infected machine. That's how the architecture was done by the Carbonac developers. So all the commands are stored there and in encrypted form, and when the Carbonac is running, it loads them and executes on the infected machine. Then we started to think, okay, we need to create a tool immediately in a really fast way to help potential victim track down the Carbonac. And look what we did. We create a batch file. Seriously, the batch file is the most fast, reliable, and effective way of tracking down the Carbonac malware. You can see it looks for the .bin file, and of course there is other indicators of compromise. It's malware after the infection. It copies itself in the Windows system directory with the SW host exe name, and also there is another directory where the .bin file could be stored. It depends on version. It's a C program data, a Mozilla folder. So if any of these files are detected on the system, you are 100% infected with Carbonac and nothing else. That's how we done it. Another interesting point is how Carbonac malware is communicating with the command and control server. It uses a simple algorithm, simple scheme. It's a HTTP protocol with a get and post request, but of course it's encrypted. And the encryption is basically RC2 plus base 64. And we're starting to think, okay, we want to dig in, we want to understand what inside this encrypted protocol, how the commands go up and down, what it's downloading, what it actually do. And we created a tool. And guess what it was? A Perl script. It was another simple, reliable, and effective way of decrypting the communication protocol. So the Carbonac sample storing inside of its body a hard-coded key, a unique hard-coded key, a decryption key actually. So we just extracted the key from the sample, put it inside the Perl script, and run it against the traffic. And after we see what's going on inside the traffic, the puzzle was fully complete.
Thank you. Wow, a Perl script, and it's not even a one-liner. These guys are good. Back to the human side of the story, back to our little tiny project that had the chance to get out of hand. This time, opposite to what we did last time, we wanted to help Kaspersky. Kaspersky was running their research, and we wanted to see if we could help them in their research. And in doing that, use the decapitated dragon. Is it even possible for law enforcement to share information with public partners? That's what we wanted to find out. And the answer, fortunately, is yes, but under certain conditions. Now, if this crouching tiger here, see this as a Venn diagram, if this crouching tiger here would be the National High-Tech Crime Unit, that's us, then Kaspersky, Jornt, to be precise, was able to do research on information we had, but not in the tiger den. He would be sitting in that little square in the top right. He would be the hidden dragon. He would be sitting there, working on a standalone PC, making notes on paper, and being observed by an officer the whole time. So is it possible to work together? Yes. Is it hard? Yes. But I guess it should be hard. Also, any private information from people he was not allowed to see. But we could exchange information in this way. And what did we do? I want to give you 2 examples of the decapitated dragon, of other things we did to make crime less, because there were no victims in the Netherlands, so we needed some other stuff. First of all, what we did is warn the banks that there was yet another attack vector. They've had them all, there was a new one. So what we did, based on a report made by Kaspersky, we have great contact with all the different banks in the Netherlands. We warned them. We gave that report. We were not the only one to do that. Europol, I'm going too fast. This, by the way, is damage mitigation. And we were not the only one to do that. Europol did exactly the same thing. They have good contacts with the banks in the rest of Europe, and they sent out the report to the rest of the bank. So, damage mitigation. Another example, credit cards. At some point, Kaspersky gave us an IP, and on that IP address, we found 1 million stolen credit cards. After deduplication, 300,000 of them were left, and of those 300,000, it turned out about 15% were not blocked. A pretty good haul. So we sent that information to ICS, and the credit cards were blocked. Very simple, very straightforward, but again, it is victim notification and it is disruption, because the criminals cannot earn money anymore with this. 2 simple examples of what you can do without a whole investigation. But imagine you are the victim and you're hurt. How does that work? How do you get hurt?
When we started work with the police organizations, we started to get additional information about the victims, about the attacks, and about how criminals are actually working. So we found out that the ATMs are just one vector of making the money. The additional vector was gaining access, grabbing access to the Oracle DB, so all archive. In this case, criminals were able to multiply their accounts in the bank. And the bank didn't know that for several hours. So criminals multiply the balance, budgets, grab it through the ATMs on their debit cards, and that's it. The other case we found was with a computer that was responsible for connection with the SWIFT. So bank was sending money transaction to other bank, but nothing was changed in the original database. So money was transferred, but nobody noticed that. The additional case was with the online banking. So the question is, can you imagine the man who can go deeper inside all the system? So he needs to be an expert. He needs to be inside in all of them. And we were thinking how it's possible. But the answer for the question was actually criminals were not educated. They had tutorials. They've got videos. Carbonac inside the code got functions to send pixels of the desktop to the servers. And that's how criminals were able to grab video stream. they got tutorials, video tutorials, how to communicate with all of these systems. And when we start working with the criminals infrastructure, we found additional videos. So, this is a Windows server that controls Carbonac. We got special video player that is specially designed to watch the video. And this video I'm going to open is really from the bank. How to operate with the online banking system. So on the top of the screen, we got additional search string. Which application you want to watch? Which application you want to educate? For example, Notepad, Outlook, and so on and so on. So we got green line, additional green line, which shows which frame of send it from Carbonac infected PC is responsible for some activity. And right now on this video, time is 8:30. The guy is going to start his daily job. And the guy is logged in. And he got the access to, RDP access to all internal infrastructure of the bank. He got RDP access to the Swift, he got RDP access to the Analyst, and additional. So what this guy is actually doing, he's running SQL queries to check, was there any failures? Maybe something went wrong during the night. And he got troubles with around 50 transactions. So right now, this guy from the bank, system administrator, is going to double check, triple check, was the money really transferred or not? So first of all, he goes to the automatic banking system and checking email, for example. Then he got the RDP access to server who is responsible for the archive inside the bank. Archive inside the bank, it's where the money are. The financial departments inside the bank are working with this archive. And what our guy is actually doing, he's going to manually push these transactions to the archive to complete money transferring. So right now everything is blurred because this is tutorial not for us.
Why not? Very curious.
But this is it. When we started to grab information about the victims, about the targets, we reached that around 100 organizations, financial institutions, and the banks are attacked by the Carbonac. And this organization in 30 countries grab a huge access to the money. Please imagine that you got access to the Oracle DB. You can multiply your balance, your budget, as much as you possible. And that's how we came up to count the damage. $300 million was the cost for the organization who asked us for help for the incident response. Then when we started working with the police organizations like Europol, Interpol, we found out that additional $300 million was reported by the victims in the previous cases of Carbonac. But then we found that additional $1 million was stolen from the financial institutions. They doesn't report the damage. They are worrying about their reputation. And that's how we came to the estimation up to $1 billion in 1.5 years. So right now all publications are ready. So you can go to the secure list. So everything should be there, all papers. And once again, conclusions. What was it?
Conclusions, lessons learned. Isn't that a bit early for a case like Carbonac? It's only just starting, but our little project is finished, and who knows what's going to happen next. So I want to give you the lessons learned of the project for us and for Kaspersky. First of all, don't ask Kaspersky for a small project. Another lesson that Kaspersky learned, if they want information from us, don't call us on Friday afternoon. What we've learned, what we've noticed, is we have two different cultures, but we learn to understand each other. What we have learned as law enforcement is that if we want to work with private industry, usually we're very secure, we're very thorough, but if we want to work with private industry, sometimes we need to hurry up and get things done faster. What parties like Kaspersky learn is that law enforcement, we have so many laws to follow. We need to be thorough, we need to be slow, we have judges involved, and we have a different way of thinking. We cannot do everything you hope we could do, but we can work together. The obstacles are not technical. Technically, we would be able to do anything we want. The obstacles are not the humans, because we want to work together and we want to solve this type of crime. The obstacles are solely judicial. And I know it should be there. And thankfully, I am not, I don't do anything with the law, but I think we need, in the coming years, we need to think of the law and see if we can upgrade it to make it more in line with the real world. But the biggest conclusion, I think, is Kaspersky and us. Would we do a thing like this again? Hell yeah!